Well, good day again, students. We are starting section 2.7, which is the last one in chapter 2, which means we're going to be heading towards a test pretty soon, probably Wednesday next week. So I want you to kind of hang on to that little detail. Secondly, is this section is on inequalities. It's a big section. All right, it's kind of big, lots of pages and a lot of stuff, but it does what algebra does. You know how to do some things now, and so it has you do all those things with inequalities. So this particular little unit goes through all those things, and so it makes it kind of a big unit. But first of all, we're gonna graph solutions on a number line. You're probably familiar with this from high school algebra. We're gonna then talk about interval notation. This, I'll put a few stars by this. This is something you may remember but did not learn well, or you may not have learned it. So this may be the new thing. At that point, we're going to solve linear inequalities. We're going to look at the properties and then solve them. And there's a unique thing happens with inequalities that doesn't happen with equations. So we have to allow for that. And then we're going to look at linear inequalities that either have no solutions, unique solutions, or all real numbers work. And then we'll do some modeling. And so, which are essentially some story problems. So it's quite a bit, and let's get going. Okay, we got a few examples here, so let's run through them. Let's do x is greater than 2. Now, when you graph inequalities, you graph them on a number line, okay? And so what we do is we make a number line here, and we label the number line. And so I'm going to do like 0, 1, 2, 3. That's enough. I don't need to put a whole bunch. I could just put 2 on there and go from there. In either case, that's what we do. So then the next thing we do is we want to be greater than 2. First of all, with inequalities, let me say that you always want the variable on the left side of the inequality, unless it's compound like this one. Compound's a different issue. But if you just have a single less than or greater than, you always want the variable on the left and the constant terms then on the right. So when we solve, we want to do this because then we read it correctly. We say we want x is a number where that number is greater than 2. So we can think of a lot of numbers greater than 2. 2.5, 3, 4, 2.1, etc. So what we see is all those numbers are to the right of 2. Now, what I do is I don't draw it on top of the number line, which is kind of what elementary school kind of does. I just put it up above the number line, and typically we put a circle for where we start, and then the direction that indicates greater than, we put a line and an arrow, and then we have to determine whether we fill in the circle or not. So the question really is 2 greater than 2? And the answer to that is no, so we leave it an open circle. Okay? Let's go on to the next one. X is greater than or equal to 2. So we put 2 on the number line. Again, it's greater than, so we know it's going to be all the values that go to the right here. All right. And it starts at 2, so that's an open circle. But it's also equal to 2, so 2 can equal 2. So what we do is we fill that in. All right. Now, then we do this as less than 2 and less than or equal to 2. All right. So less than 2, we'll have an open circle at 2. It's not equal to 2, but less than is all the numbers to the left. So this is where understanding less than means to the left and greater than means to the right helps you to draw it in the correct direction. If it's less than or equal to 2, then we would fill in the circle because we're equal, and then we would draw to the left. So those are the correct graphs in each situation. So now I want to show you something. I'm going to erase a little bit. I'm going to erase the circles. The whole circle thing was something I actually learned in elementary school when I first learned how to do these. But what we are going to do is, instead of use an open circle for when they're not equal, we're going to use a parenthesis like this. Okay? And when they're equal, we're going to use a bracket like this. Okay? And so this one, it was not equal to 2, so it'll be a parenthesis. And this one was equal to 2, so we would put a closed bracket. Now, there's a reason I'm using brackets and parentheses instead of open and closed circles. Now, if you use open and closed circles on a test, that's fine. But like I said, there is a reason I am doing this. We're going to look at that reason in just a moment. Okay? All right, one more to do is when you have a compound inequality, and a compound inequality wants you to graph both of these at the same time. So we have from -2 to 2. And this part of the inequality says x is less than 2. So I'm going this way. But this part of the inequality says -2 is less than x, which is the same thing as saying x is greater than -2. So that means by the parenthesis, I go this way. And so what we notice is that in this case, we have the parenthesis because they're not equal to 2 or -2 on either side, but x is between those, okay? Now, sometimes we can have a compound inequality where they might go the other direction, and half of it might be actually equal, but the other half is an open parenthesis. So those are some examples of what can happen, but that's how we graph an inequality. So let's now talk about interval notation. So I'm going to push this over here like this, and we're now going to talk about interval notation. So interval notation is the way mathematicians write inequalities as you get more advanced. So I would say almost always in pre-calc and above courses, you write inequalities in interval notations. And so what we have on this first one is we have x is greater than 2. But if we look at the number line, I have a parenthesis on 2 because 2 is the smallest number in the interval. So what's the largest number in the interval? Well, this arrow indicates it goes on forever towards or in the direction of positive infinity. So what the largest number or the largest direction would be positive infinity. And you can never equal that, so that's always an open parenthesis. Okay? Now, in the same way, if we move to x is greater than or equal to -2, x is greater than or equal to 2, then notice how we used a bracket right there. All right? Because it was equal. Well, using that bracket is what you do when you make the interval. And so then we understand that we're equal to 2 and we go in the direction of positive infinity. So this becomes the interval notation for that one right there. And now for less than, we go in the opposite direction. X less than 2. In this case, it travels towards negative infinity forever. And so you always list what comes first. So it's negative infinity up to 2. We're not equal to 2, so we put a parenthesis. And we can never equal infinity, and so we put a parenthesis. And then we do less than or equal to 2, and we would do that the same way. Except the difference would be, since we're going up to 2, we would put it, and we're equal to 2, we would put a bracket on that. What about this case here on the bottom, where we have negative 2 is less than x is less than 2? Well, now we're in between two numbers, but we don't include them. But see the parentheses? Put the smallest number, then the largest number, and the parentheses. And I know this looks like an ordered pair, but in this context, it's understood as x is in this interval, okay? In fact, we often write things like x is an element of that interval, okay? If this had been negative 2 is less than or equal to x is less than or equal to 2, then we would have used square brackets to indicate all the numbers between negative 2 and 2. Okay, quick review of interval notation. So you want to practice this by writing your answers this way. Okay, next slide. So it turns out when we solve linear inequality, we use all the same properties. We have an addition property of inequalities where we can add the same number to both sides, right? So add 5 to both sides. And we end up getting x is greater than or equal to 7, which we would then draw on a graph. So here's 7. I'm greater than or equal to 7. So I'm a square bracket and everything to the right. And I would write it in interval notation. 7 is the smallest number. Positive infinity is the largest. So this would be the correct interval. And that's pretty much it whenever you add. But what if you start to have more complicated problems where you have to use the multiplication property of equality, which we didn't use on this one, the multiplication property of inequality? Well, there's something interesting that happens. Now, suppose I know that 3 is bigger than 2 as an inequality. Now, if I multiply both sides by a negative number, say I multiply negative 1 times 3 and negative 1 times 2, okay? That gives me negative 3 and negative 2. But negative 3 is less than. So what's the difference? I multiplied both sides by the same thing, but it changed the direction of the inequality. And so whenever you multiply both sides by a negative, you have to change the direction of the inequality. And that's a key to being able to do these problems. Okay? Let's do one quick example. Oh, I wrote it there. You saw me writing it. Sorry about that. So here's our problem. And so now we want to solve this problem. And we're going to follow the same four-step process we do with equations. So I see distributive properties, so I'm going to do those. So these are my helps, so I don't forget to multiply. So I get 7 minus 2x plus 8 is less than 5 plus 10x. And now I collect like terms. 7 and 8 are 15. So negative 2x plus 15 is less than 5 plus 10x. And now I use the addition property of equality. I add negative 15 to both sides. That'll get rid of the 15 over here, make it 0. And then I subtract 10x from both sides. And that makes that 0 there. And I end up with negative 12x is less than negative 10. So I need to solve that. But what I want you to notice is I'm going to divide by a negative. So the one thing I do to not make a mistake, since I'm going to divide by a negative, I rewrite it, change the inequality. So I don't do it right underneath. I actually add a step to my equation inequality solving process to make sure that since I now notice I'm multiplying or dividing by a negative, I need to change the direction of the inequality. And I have now done that, and I get x is greater than 5 over 6. I would then draw that on a number line. So it's greater than that. And I would write the interval notation. 5, 6 is the smallest number. It's not equal, comma, the largest number in this case would be positive infinity. And there are the 3 ways I would write the answer. Okay? So that's solving an inequality. So there's a little bit more I need to do this video. I'll finish it at school. So I'm back to making this video, and I just wanted to mention every time you multiply or divide both sides of an inequality by a negative, you have to switch the direction of the inequality. So here I switched from less than to greater than. Now what I do to remember this is when I notice that I'm going to divide both sides by a negative, I notice that here. I don't just write it here and then forget to change this around. What I do is I rewrite it, and when I write that here, then I change it around. And I made so many mistakes learning algebra and forgetting this, that I needed to do something so I would remember to change the inequality when I multiplied or divided by a negative. And so it's a fairly important part of the multiplication property of inequality, that if you multiply or divide both sides by a positive, the inequality stays the same, but if you do a negative, it changes because of this property. When you multiply by a negative, it just switches things to being from greater than something to less than something. Okay? So remember that. Let's go on and look at a couple other problems and finish this video. So here's our equation, and what we do is we're going to proceed to solve. We get 7x is less than or equal to 7x minus 14, doing our distributive property here. And then we subtract 7x from both sides. And we end up with 0 is less than or equal to negative 14. Now this is always false. And if it's always false, then that means there is no solution. Okay? Which you can also illustrate by putting this symbol or this symbol, which mean the empty set. The empty set is a set which contains no solutions. All right? It contains nothing, so it doesn't have anything in it. So it's considered the empty set. And these are the mathematical symbols we use for those. All right? So here's a story problem that looks like that's an inequality. So an elevator at a construction site has a maximum capacity of 3,000 pounds. What that means is that the weight on the elevator has to be less than or equal to 3,000, right? That's the maximum it can be. So everything you put on it has to be less. So this is a key mathematical term and very practical way to think about it at a construction elevator. Now the operator is 245 pounds and each cement bag weighs 95 pounds. How many bags of cement can be safely transported on the elevator? So what we need to do is write the weight that's on the elevator. So I know the dude running the elevator is 245 pounds. So I'm going to add that to 95 pounds for a bag of cement. But I don't know how many bags of cement I have. So I'm going to multiply that by the variable x. So 245 pounds plus 95 times x. That represents the total weight. Okay? So in some sense, what you're saying is the weight has to be less than or equal to 3,000, the capacity of the elevator. And I'm trying to find an expression for the weight, which I've done there. Okay? So now I solve it. So I subtract 245 from both sides, right? I get 95x is less than or equal to 2,755. And then I divide by 95 on both sides, right? And that gives me x is less than or equal to, let me do this on a, well, let's go to the calculator. Oh my gosh. Why not go to the calculator? So it's 2755 divided by 95. 2755 divided by 95. And that is 29 bags of cement. So x is less than or equal to 29. And so a maximum of 29 bags of cement can be transported. On elevator. Now, I usually like to indicate that writing a complete sentence like this is a good way to answer a story problem, because now I know that I can have up to a maximum of 29 bags, and I can put that many on the elevator and transport it. Just so you know, if desired, you could you have less than 29, and so it's actual bags. So you only actually go to, excuse me, you go to 0 here. So, because you can put 0 bags on the elevator, and you could put any number up to 29. So this is a closed interval, so you can go from 0 to 29 bags. And that's what's different about a practical problem. It's less than 29, but a negative bag of cement is not a real object. So actually putting this on a number line or in an interval notation gives you a slightly bit more bit of insight into how you would write the mathematics for this problem. Okay, let's wrap this up. So as I was saying, to wrap up, to be prepared for Monday's class, you want to finish the homework for 2.5 and 2.6 and ask any questions about that. And then after watching this video, if you have any questions about this video and inequalities, or if there's problems you want to see again when you kind of look over the problems, make sure you ask me. Okay, so don't turn in blank problems. Ask those questions in class, and you can get them done in class. All right, and let's make sure that we come prepared every week. All right, bye. We'll see you later.